Okay. Now let's have a look. So this course is about AWS Cloud Practitioner. So this is about AWS Cloud Practitioner. So AWS provide infrastructures as a service. Infrastructures as a service means, let's say AWS has cloud environment. In the cloud environment, this is, let's say, the cloud environment. Over there, we have, let's say, virtual machines, storage, right? We have application services running, many security features we have, database we have, file services we have. All these services we have in the cloud. You can create virtual machines. You can create storage account, storage over there. You can store your files and stuffs over there. Applications you can deploy. You can deploy application. Then database services. Then database services you can have over there. Many different monitoring tools we have. All these services we have in the cloud. Let's say previously on premises, we used to have storage account. We had Hyper-V or VMware. Top of that, we could create virtual machines. We can deploy some applications in locally. We can have database services locally. But now everything we can have in the cloud. So this is about AWS Cloud Practitioner. So AWS Cloud basically, and this is, we call it more on AWS infrastructures as a service. They provide infrastructures, and based on your company requirements, you can use these services. And after that, it's more on subscriptions basis. You can purchase, hourly basis you have to pay. Let's say you create one virtual machines and it is running for, or always is running, let's say. So whatever time is running monthly, you have to pay for that. Any services running, you have to pay for that services basically. And experiment purposes, production deployment purposes, you can use this one. And in this way, management is a lot of easier. Let's say you do not have any initial setup cost. Let's say you are a developer, or like your company want to deploy one of the applications, or you want to do some experiments. So you don't have to purchase any hardware. Simply you sign up. After that, you can log in over there, and you can straightaway start to use the services. That is the main advantage. So you can save time and initial cost you can save as well. This is the advantage we have with the AWS infrastructure. So this course, you're going to look at the fundamentals of these topics, like how to use this portal, how to configure some of the stuffs over there. Those kind of things we're going to have a look. Now let's have a look at our first topics. The cloud, module 1. This section is going to look at cloud concepts, define the AWS cloud and its value proposition, identify aspects of AWS cloud economics, list the different cloud architecture design principles. These are the topics mostly we're going to have a look. Now, what is cloud computing? So using a public cloud is about using other people's servers to run your digital workloads. So that means AWS, they have data centers, they have physical servers over there, they have all the services running, and with this portal or applications, remotely we are logging to their services. We are using the service in the portal, but the service is running somewhere. So physically they are running. It's the same thing. Let's say if I have some computer running and if I provide you remote access, you're using this one. So for you, like you're just using from the browser, but for us, we have the physical servers. So similar to that, cloud computing means you're accessing the resources. Let's say your Gmail you're using, or Facebook, or anything you're using. Basically, they are all part of cloud computing. You're just using, or I'm using the apps, but you save your pictures, you upload your video, but those video and pictures, they need to store some physical servers. So for you, is like a just simply apps and things, but in the back end, they have the entire servers, storage, network, everything. And people, they are managing regular basis, those things. In a sense, there is no significant difference between running a software applications on servers hosted in your own office versus located within Amazon's infrastructure. In both cases, you need to make sure you have got sufficient compute memory, network, storage, and resources. That means whatever you're doing on their side, they need to have a proper storage space, proper network connectivity, enough memory in the servers. All these things they're going to provide. In both cases, fast deployments and avoiding over provisioning are key goals. So it's faster. But particularly when it comes to largest cloud provider, there are important differences. The sheer size of a platform like AWS means it can offer you service, cost, reliability, performance, and you could probably never hope to recreate your own on your own. So that means they have a huge infrastructure. So that means if your company is very large company, they have complex infrastructures, still they can deploy something in AWS. Now, highly available and scalable resources. Design multiple layers of redundancy so that whenever one component fails, its workload is particularly and instantly moved to a healthy replacement. So they have high availability and scalability. That means on their side, let's say you think, okay, I'm using Facebook, but have you seen ever like Facebook is down? Or have you seen ever like Google is down? Because still they need maintenance. If something happened, they have redundant services. So redundant services start to work. If something happened, like in once, they have a backup there, which you'll not see from your this you see, oh, always my application is working. Connect resources in geographically remote locations so that the failure of one component region could trigger a predefined relocations. These relocations can be supported by a similarly automated rerouting of network request. Provide customers with access to as much compute power as they could possibly need and deliver that power on demand. Because of the scale and efficiency of the platform, AWS can do all that at a price that's often far below what it costs to run compared workloads locally. So they have very efficiency, and they design the platform in such a way that overall reasonable cost you can run your workloads over there. And on demand means you can, let's say, you need the services, your applications you want to run on the daytime. You can probably particular hour you run, and after that, if you shut down, there'll be no charge for that. Those kind of advantage also you have. Professionally secured infrastructure. So IT security is constantly moving target. As difficult as it's been to manage last year's threats, there's a whole new batch coming right behind them. As a business, you're already responsible for protecting the workstations and networking hardware running in your office, along with the securing your organization's data and code your developers put into your apps. The integrity of your underlying server infrastructure is just one more potential area of vulnerability for you to worry about. No matter how good your IT security team, probably not better informed, equipped, or trained than their counterparts at a major cloud provider. So AWS is good in this case because it takes responsibility for the security of its platform underlying networking and compute infrastructures. This is one area where outsourcing will easily make sense. This is talking about more on, let's say, why you're going to use their services. Is it secure? So yes, it is secured. Even underlying, because you can see the apps, but you do not see the underlying hardware infrastructure. So over there also they maintain security. All the server security, network security. So pretty much they provide all the security. Metered payment model. So one of the defining characteristics of any public cloud computing platform is the way it automatically allocates resources to meet client request. This means that you can, for instance, log into the AWS browser console and define and launch a virtual server, and moments later your new instance will be ready for you. There's no need to wait manual interventions in AWS employees. That means kind of like you can do your own task. You can manage your own staffs. You don't need to contact with their employees. The flexibility of self-serve system permits usage patterns that would have been impossible using traditional compute paradigms. Now, testing. Let's say you'd like to test something. You want to deploy some applications and you need some servers, so you can quickly deploy your applications over there and see how it's working. So you do not need any physical server room and all these stuffs like old days. Now, once the tested ended, you would still be paying the maintenance and ownership's cost of the server capacity, even if it was idle. In the cloud, by contrast, you fire up an instance. Instance means VM, virtual machines. Run it for the length of your time and then shut down. That means if you run your VM for a couple of days, do some experiment, after that you delete, you should be fine. So you don't have to pay anything. So whenever you're using, you just pay only on the time. That is actually called metered payment model. You'll be billed only for that testing time, which in some cases could cost you fractions of penny. Maybe you need a very high maybe you need a very high spec computing services, so you cannot purchase that one, is expensive. But over there you just use for a couple of days, you do your experiment, and after that you remove everything. So that kind of flexibility we have over there. So that means those kind of things, if you do, it will be cheaper.
This means we have to use the virtual machine.
Yeah, so you can create virtual machines over there in the cloud. Everything we talk about inside the cloud. So basically, since there is no human processing involved in the cloud compute billing, it is easy to provide a charge a few pennies as it is thousands of dollars. This meter payment makes it possible to consider entirely new ways of testing and delivering your applications. And it often means your cost cycle expenses will be considerably lower than they would if you were using physical servers running on premises. Comparing the cost of cloud deployments against on-premises deployment requires that a fully account for both capital expense, which is CapEx, and operating expenses, which is OpEx. Yes. So CapEx means capital expenses, like when you need a capital to purchase all the goods. But operating means, so when you go to cloud computing, so CapEx is not required. You need just operating expenses, basically. On-premises infrastructure tends to be very CapEx heavy since you have to purchase all the expensive hardware upfront. But cloud operations, on the other hand, involve virtually no CapEx cost. Instead, your costs are ongoing, consisting mostly of per hour resource rental fees. It's kind of like you renting the service, basically. You can have your own house or you can rent. So it's similar to that, basically. Yeah, these days maybe house cost is more than very high. So whenever you rent, maybe all of your life you don't pay that much. What about the house cost? Yeah. So server virtualization. So virtualization is one of the important things. Let's say in a company, like let's say if you want to deploy anything, you need a lot of servers. 1, 2, 3, 4, 5 servers. But virtualizations make things easy. Instead of purchasing all the physical servers, you can simply deploy virtual machines and you can perform your task over there. The secret sauce that lets you cloud providers give their customers on-demand computer resources in such a wide range of configurations is virtualizations. When you request a virtual machines with a particular processor speed, memory capacity, and storage size, AWS does not send some poor engineering running through the halls of its data center looking for an available machines with exactly profile. In here is saying they say compute, storage, and then you have the hypervisor. Top of that, you have all these virtual machines. And also you can attach your hard disk over there. AWS carves the necessary resources from larger existing devices, VMs accessing storage and compute resources from their host servers. It's the same thing. Let's say if you create virtual machines in this computer, you can create 1, 2, 3 like that, but it depends on how much capacity you have in the physical servers. So because when you create a VM also need like memory, hard disk, all this stuff. But how it will get those stuff? It will get from your actual device. So when you create virtual machines in the cloud, you create 1 VM, 2 VM like that. But in the backend, they consuming the resources from the actual their server. Let's say this is a server, right? Top of that, this VM is running. So more VM you create, more storage, network connectivity, memory, those kind of things you need. Multiple times we can access. Yes. Now, server virtualization is basic. A 5 terabyte storage drive could, for instance, be divided into dozens of smaller virtual volumes, each associated with a different virtual servers. And resources of a single physical server could be invisibly shared between multiple instances. It's saying that what is the advantage with the virtualizations? If you purchase one physical server, it costs a lot. And top of that, you can create many virtual machines. So in this way, you can reduce the cost. Like if you have one physical server, top of that, maybe many physical servers, top of that, hundreds of VM running. Then operating systems installed on each of those instances could run, blissfully unaware that there are actually only masters over a small subset of a much larger server environment. The virtualization model offers two compelling benefits: speed. So it's like faster. To deploy a VM is faster. Defining, purchasing, provisioning, testing, and launching a new physical server can take months. Even a simple reboot can take a long time. But the time lag between requesting a new cloud-based VM and logging in and getting to work can be seconds, but never more than a few minutes. Restarting a VM can sometimes happen faster than you can type your login details. So that means it's very fast over there because they have enough, those servers and everything is there. They have a very strong, capacity. So that's why if you create a VM, it will be faster. Efficiency. It's rare to find non-virtualized physical server that utilize anywhere near 100% of its capacity. More likely, either it will spend its time running mostly empty or it will be badly overused while you wait for capacity to come online. So if you do not do virtualizations, let's say this PC may have 1 terabyte space, but you're not using all of them, just sitting there. But if something happens, then maybe it will everything you need. But when you create virtual machines, it's actually you're utilizing all of your resources evenly. That's one of the advantage we have. So that means efficiently you can utilize your server and all the server resources. Yeah, so multiple virtual machines, on the other hand, can be tightly packed into a physical server running a hypervisor. When space opens um, up on one server, you can quickly fill it with another server workload. When a server reaches capacity, overflow workloads can be moved to another machines. And the more workloads you are managing, the more flexible everything gets. So if more resources is required or if virtual machines is filled or something, so it will be running from another servers. Now, cloud platform model, we have infrastructures as a service. Infrastructures as a service products generally simulate the look and feel you would get from managing physical resources. Infrastructures as a service product give you direct access to providers' compute, storage, and network assets. Because it's you that's in there playing around at the hardware level, you rather than that the infrastructures as a service provider are responsible for the consequence of any bad configurations. The trade-off is that you get to closely configure every layer of your operating stack. AWS infrastructures as a service provide Elastic Cloud Compute EC2 for virtual machines instances, Elastic Block Store for storage volumes, and Elastic Load Balancing. So AWS infrastructures provide EC2 means Elastic Cloud Computing. That's the virtual machines you can have. Elastic Block Store means a huge amount of storage you can get. Let's say you have terabytes and terabytes of files, you'll be able to store over there.
AWS is kind of a storage.
Yeah, it has a huge storage. Yeah. Maybe in Microsoft, you have used OneDrive. Similar to Google has a Google Drive. But that is more on software as a service, but this is more on, let's say, a company, you have a terabytes of data. So you need to store, maybe you store some server, but you can store in the cloud. Then platform as a service. So unlike infrastructure as a service, platform as a service products simplify the process of building an applications by hiding the complexity of the infrastructures that runs it. You're given an interface through which you define the behavior and environment you want for your applications. This will often include the code that will run your applications. AWS Platform as a Service products include Elastic Beanstalk, Elastic Container Services. So platform means they have the platform. Top of that, you can deploy your applications. And what is software as a service? This is already you have looked at Microsoft 365 is a software as a service. Google Gmail is a software as a service. So all these, they are software as a service. AWS SaaS products arguably include simply email service and Amazon Workspace. Yeah. AWS do not have like directly that kind of software as a service, but that's why they're saying while some may disagree with the designations, yes, I mean, they don't have actually software as a service. They trying to make or something, but more infrastructures is mostly people using for that. So this one is a bit of comparison. Let's say compares the scope of responsibility you have on infrastructure as a service, platform as a service, and software as a service platforms with the way it works for on-premises deployments. The breakdown of responsibility across multiple infrastructure types we have, let's say on-premises applications code, security, database, operating system, virtualizations, networking, storage hardware, server hardware, everything we manage, our responsibility. But when you go to infrastructure as a service, application, security, database, operating system, we manage. But the cloud platform responsibility like virtualizations, networking, server hardware, storage hardware, those things managed by service provider, which is AWS. And you can see platform as a service, only applications we manage, but the rest of the things managed by cloud provider. Software as a service, everything managed by the cloud provider. We just manage our data. Let's say Microsoft email data, but they provide everything. OneDrive, you just put your everything, but they manage the backend. You just manage your data. Now, another thing called serverless workloads. Besides doing an excellent job emulating traditional server behavior, cloud providers can also enable entirely new ways to administrate applications and data. Perhaps the most obvious example is serverless computing. So what serverless does allow is for individual developers to run their code for seconds or minutes at a time on some else cloud servers. Serverless model as provided by services like AWS Lambda make it possible design code reacts to external events. Serverless means you do not have to think about servers. You don't have to manage the servers, but you just manage your applications. And in the backend, they're going to manage the servers, but you just manage your applications simply. So in this way, less management. Let's say you don't have time to manage servers. So you don't have to worry about servers at all. You just think about your applications only. When, for instance, a video file is uploaded to a repository like AWS bucket or even an on-premises FTP site, it can trigger a Lambda functions that will convert the file to a new video format. There's no need to maintain and pay for an actual instance running 24/7. So just for the moments your code is actually running and there is no administration overhead to worry about. So serverless workloads is also one of the popular things inside the, um, yeah. Let's say you are using Gmail. You worry about anything? No, just your Gmail is okay or not. That's it. Similar to that, like as serverless, you just think about, like, especially for the developer or the company, they're going to think about only that applications part, not for the other things.
So the developer, you don't need to type the code and everything.
No, server, they don't have to think, but still they need to have their code and everything, yes. Let's say they write down all the code, they need to deploy. You can deploy in the cloud, but you don't have to think about underlying all the services. Now, scalability. Scalability means, let's say, based on your requirements, you can add more resources, you can make it less. Let's say you need more memory, you can add. But let's say now your work is done, you don't need more memory, you can reduce that one. So scalable service will automatically grow in capacity to seamlessly meet any changes in demand. A well-designed cloud-based operations will constantly monitor the health of its application stack and respond whenever preset performance metrics might soon go unmet. The response might include automatically launching new server instances to add extra compute power to your existing cluster. But it will probably also involve pre-populating those instances with the application's data and configuration settings they will need to serve your applications to your clients. A large cloud provider like AWS will, for all practical purpose, have endless available capacity. So the only practical limit to maximize size your application is your organization's budget. That means pretty much they have many options. Let's say you need 10 terabyte or petabyte scale data to store, or you need hundreds or hundreds of VM. They can provide, they have enough capacity. Just how big is AWS? Well, if it can handle the capacity stresses required to keep millions of Netflix customers happy, and if you have ever watched a movie on the AWS hosted Netflix, then you know it can. Then AWS will surely be able to keep you up with whatever trouble your applications send its way. So that means they can host huge, servers and services, and they are kind of like a live services is running top of this AWS. Elasticity, the reason the word elastic is used in the names of so many AWS services like Elastic Cloud, Compute Cloud, Elastic Load Balancing, Elastic Beanstalk, and so on, is because those services are built to be easily and automatically resized. Generally, you set the maximum and minimum performance levels you want for your applications, and the AWS service you are using will automatically add or remove resources to meet changing usage demands. By way of illustrations, a scalable e-commerce website could be configured to function using just a single server during low demand periods, and any number of additional servers could be automatically brought online when demand spikes. It's kind of elasticity means, yeah, expand. So based on your requirements, it can expand, it can shrink as well. So when demand drops back down, unused servers will be shut down automatically. Assuming you don't already have one, now is the time to create your own AWS account. Working through the rest of the topics, so pretty much you're going to look at the account and all these stuffs. Yeah, this is just the instructions how to create the account. So you're going to create the account and we're going to work around that areas. So this chapter is more on introduction part, like what is AWS, what is AWS Cloud, what are the things we can do over there. So what is their capacity and some of the features, some of the advantage we have to move our stuffs in the cloud. So pretty much these are the topics we have looked at in here.